Okay, now we're going to start looking at two-step equations. The last videos you looked at were solving one-step equations. So we're going to solve two-step equations. But before we get into that, we're going to look at some problems that you probably already know how to do. For example, if I give you 3 times 2 plus 5. So this is not an equation, this is an expression. Equations have equal signs, expressions don't. And when you evaluate this expression, you have to follow order of operations, and there's only 4 steps to order of operations. And for our purposes, we're only going to look at 2 steps right now. We're going to look at multiply and divide. So we know the order of operations is parentheses, exponents, multiply and divide, add and subtract, PEMDAS. Most people write it like this. But there's only 4 steps. Parentheses, exponents, multiplication and division from left to right, add and subtract from left to right. So there's only 4 steps. And we don't really have these when we're talking about these types of equations, so we're just going to look at this. We don't have parentheses here because parentheses means work inside them and there's nothing to do inside. So all we're going to do here, this means multiply. So we're going to do the multiplication first. So I do 3 times 2 gives me 6 plus 5. So I did multiplication there. And now I'm going to add. 6 plus 5 gives me 11. So I did addition second. Now I'm going to give you another problem, but this is going to be an equation. I want you to see the difference. 3 times some number plus 5 is equal to 11. So I'm hoping you can see that this is the same problem, except we're trying to figure out what this number is. And I'm hoping you can see that it's that 2. 3 times 2 plus 5 equals 11. So I have 3 times some number plus 5 is 11. So I like to call this problem working backwards from this problem. So since when we're working forwards, we do multiplication first, then addition, when we work backwards on this equation, we're going to deal with the adding, subtracting part, and then the multiplying and dividing part second. So to solve this, we're going to do what we've been talking about. We split it down the middle. And now we say, okay, where's the variable, on the left or the right? It's on the left here. Now I have to get rid of 2 things. I have to get rid of this times 3 and this plus 5. Well, what are we going to get rid of first, the times 3 or the plus 5? Since we're working backwards, we're going to get rid of the last thing that we did, which was the adding. So I'm going to get rid of the adding 5 first. What's the opposite of adding 5? We're going to add a negative 5. So I'm going to add a negative 5 over here. I draw my line all the way across. Now we have 3 addition problems. 3x plus nothing is 3x. 5 and a negative 5, there's your 0. Bring down your equal sign. 11 and a negative 5. These negative 5s cancel out 5 positives, leaving with 6 positives. Now we look at our equation. Where's the variable? On the left. What do we have to get rid of? We have to get rid of multiplying by 3. So we divide by 3. So we're going to divide this side by 3 with a nice little fraction. We'll divide this side by 3 with a nice little fraction. That cancels out to a 1x, which is x. And 6 divided by 3 gives me 2. All right, we're going to do a few examples here. I'm just going to make some examples up. And I'm going to make some up that will give us some weird stuff happening once in a while too. So let's take a look at this. Negative 3x minus 4 equals 13. All right, so I'm going to do the same thing. I split it down the middle. Here's my variable on the left. I need to get rid of a negative 3 and a negative 4. This negative 3 is being multiplied by the x there. So this must be a minus 4 here. Negative 3x minus 4. So what do I get rid of first? Do I get rid of multiplying or dividing, or do I get rid of adding or subtracting first? We always get rid of adding or subtracting first because order of operations is going backwards. How do you get rid of subtracting 4? We're going to add 4. Or how do you get rid of a negative 4? You're going to give a positive 4. So I'm going to add a positive 4 over here. Now I have 3 little addition problems. Negative 3x plus nothing is negative 3x. Negative 4 and positive 4, they're your opposites, always go to 0. Bring down your equal sign. 13 plus 4 gives me 17. Now we go back to our variable. It's on the left still. What do we want to get rid of? A negative 3. How do you get rid of multiplying by a negative 3? You divide by a negative 3. Nice, neat little fraction. So we jump over here and divide by a negative 3. Negative 3 divided by negative 3 is a 1x, and 1x is x. Bring down your equal sign. 17 divided by negative 3, it doesn't go in there evenly, it doesn't go in there nicely, so it's some decimal. I always tell my kids, algebra, we like fractions. I like to move the negative sign to the top and just leave it as negative 17 thirds. Let's take a look at another one, problem 2. How about we do x over 5 plus 3 equals 9. All right, so some number divided by 5 plus 3 gives me 9. Split it down the middle. My variable's on the left or on the right? It's on the left. What 2 things do I have to get rid of? I have to get rid of dividing by 5 and adding 3. What do we get rid of first? We get rid of the adding, subtracting part first. How do you get rid of adding 3? You add a negative 3. Or you add a negative 3 over there. Draw your line all the way across. You have 3 little addition problems. What's x minus x over 5 plus nothing is x over 5. Positive 3 and negative 3 goes to 0. Bring down your equal sign. 6 minus 3 gives me 5. 9 minus 3 gives me 6. All right, how do you get rid of dividing by 5? We multiply by 5. And remember what I told you? You put parentheses around that and you put a little 5 up here. Looks just like this. What's 5 divided by 5? That part turns into a 1, and 1 times x is x. We have to multiply the right side by 5, following our golden rule. 6 times 5 gives me 30. And again, you could test that. Plug it back in here. 30 divided by 5 gives me 6, plus 3 gives me 9. That worked. So let's see what happens if we throw some negative signs around and stuff. So here's number 3. That marker's dying. They're all kind of dying. Let's do this. Negative 7 is equal to 3 minus 5x. Split it down the middle. Where's your variable, left or right? It's on the right. What 2 things do I have to get rid of? 3 or negative 5? I have to get rid of both 3 and negative 5. So what do we get rid of first? All right, this is multiplying, x is being multiplied by a negative 5 here, so I'm not going to get rid of that yet. And I also have to get rid of this 3. Now again, remember what we talked about. All that matters is what's out in front here. Is this a positive 3 or a negative 3? That's a positive 3. It doesn't matter what's back here, so you can kind of forget about that. How do you get rid of a positive 3? You add a negative 3. Add a negative 3, because remember on this first step you're always adding and subtracting. Alright, now you have 3 little addition problems. A negative 7 and a negative 3, that's a total of negative 10. Nobody cancels anybody out. Bring down your equal sign. Positive 3 and negative 3, those are opposites. They cancel out, giving you a 0. Now look what's left here. That's a negative 5x, so make sure you bring that negative sign down. So I have negative 5x. Now we can divide by negative 5. Nice little fraction. Divide by a negative 5. Negative 10 divided by negative 5 gives me a positive 2. Bring down your equal sign. Negative 5 divided by negative 5 gives me a 1x. And 1 times x is x. So there's my answer. I think that's enough on that one. My guess is you can probably take it from there. All right.